In problem 1.3, we're looking at the symmetry and kaleidoscope designs. And if you've never seen or used a kaleidoscope, it's a tube containing colored beads or pieces of glass, and the mirrors inside of it allow you to see different designs as you turn the tube. It was actually patented in 1817 by a Scottish scientist, Sir David Brewster, and he was intrigued by the science of nature, developed the kaleidoscope to simulate designs he saw in the world around him. And so we actually see kaleidoscope types of images in our world. Snowflake is probably the most famous or well-known idea of a kaleidoscope design. So we're going to look at 6 kaleidoscope designs. We're going to keep track of angles of rotation and lines of symmetry. So we're going to make a table that goes with our work for this part. So as we do each problem, I'm just going to keep track of all the information here and then transfer it over to a table. So if we look at image A, we're looking for 2 things. We're looking for an angle of rotation and number of lines of symmetry. So on the first one, if we're looking for lines of symmetry, we're looking for places that we could fold it over. We're trying to find out how many of those lines of symmetry there are. So if you look at this one, there's a line of symmetry, and the question is, could I put it there and get a line of symmetry, it looks like. And then if I do there, right there, another line of symmetry. So I'm using my mirror to find lines of symmetry in this shape. And so it looks like every one of these is a line of symmetry. Now you have to be careful in counting them, because this whole entire line all the way across, that's one line of symmetry. And then here's another line of symmetry. And then another line of symmetry. All these lines, 1, 2, 3, 4, 5, and then 6 lines of symmetry. So if I take that entire image, each one of those gives me a line of symmetry. So I have 6 lines of symmetry. And then the question is, how far do I have to rotate this image before it reappears on itself? And so you have to be careful, because it looks like if I rotate it from here to there, from here to there, so I'm again looking to see how far is the rotation before the image reappears on itself. So I'm going to actually turn the book here and see if we can see that. So if I go just like that, there it is again. So that's the angle of rotation from the original. So I have to go that far to get to the next one, and then from there and there and there. And so the angle of rotation, it looks like I have 6 lines of symmetry, but I also have 1, 2, 3, 4, 5, 6 rotations. And so if I think about that angle of rotation is 360 divided by 6. And so I get 60 degrees for each of those angles of rotation. So I have 6 lines of symmetry and 60-degree angles of rotation for image A. So let's look at image B. Image B, maybe this time I'll start with the rotation angle. So if you think about this, and part of the way to figure this out is if you look at this half moon image here, how far would I have to rotate it before it's in its original position again? So I could take this one here and bring it up to there, or I could take this one here and bring it to that one. So I've got to go from here all the way around to that point, and then all the way around to this point to get those moons, because you have moons facing opposite directions, and if I'm not careful, they will not be in the right space. So you can see that I'm going to have 3 angles of rotation. And it's interesting because if you think about lines of symmetry, so if I have the moons again, moons are kind of the trick on this one. See, the moon there is back to back at the top of the image. So I have the moons correct. So 1, 2, and looks looks like three lines of symmetry. So I have a line of symmetry here, a line of symmetry here, and a line of symmetry here. So I have 3 lines, and I have 120 degrees for each section, because if I take 360 divided by 3, that equals the 120 degrees that I got for each of these angles. So 120, 120, 120. And so that was the 360 divided by 3 equals the 120 degrees for each angle of rotation. Now, image C is interesting because it has words printed on it, and words can create some challenges when it comes to symmetry. And so, in this case, if I'm looking for lines of symmetry, and especially with words, and we see we have the word time in 3 places here, and we have the word math going up and down. So if I put my mirror on here, I should see math, time, and the divide symbol. And so if I lay it on there, you can see that the words math, time kind of get messed up. Can't even see them. The math is there, but it doesn't quite work out right for the time part. And you can see that no matter where I move it, any place I move this, the divide symbols aren't in the right place. The math word, the only thing I get some symmetry on is the word math. And so it looks like there are no lines of symmetry for this image. But it does look like I could rotate it. Looks like I could take it from math from here and rotate it to math there, and then another rotation here, and then one more rotation. So it looks like I can get 3 rotations. So I have 360 divided by 3, or 120 degrees for each of those rotations. Now this one's kind of an odd image because it's not really truly a kaleidoscope, and so there's not as much symmetry as we would expect to have because of the words. Words are one way to sort of mess up the symmetry design of the kaleidoscope image. So that one has no lines of symmetry and 120 degree angles of rotation. So it still does have rotation symmetry, even though it does not have reflection symmetry. So let's take a look at D. And D looks like one that has lots of symmetry. It looks like I can, let's start with rotation. If I rotate it, the question is how far could I rotate it and get it back to its original image. So it looks like I can go from, let's use one of these points, from here to here, and then from each of these points, if I take each of those spots and rotate them into the next place, it looks like I have 6 rotations. Now it's interesting, when I have 6 rotations, it also looks like those points, any place that I've rotated it, for example right there, it's a point of rotation, and it gives me back my original image. What about if I put it there? Does that give me back my original image? So sure enough, I still get original image. So there's all these, a whole bunch of, there's 1, 2, 3, 4, 5, 6 lines of symmetry. So I have 6 lines of symmetry. And then I have the 6 rotations, 360 degrees divided by 6, or 60 degrees for each of these rotations. So I have 60 degree rotation symmetry, I have 6 lines of reflection symmetry for image D. Now image E. Zoom in on this one just a little bit more. Let's see this one. Image E, if you notice, there are 3 yellow flowers here. And so just looking at that, if I just use the yellow flowers, and then we have this sort of set of white ones, and we have this sets of purple ones, you notice they're all in sets of 3, which sort of gives away the rotation symmetry here, because if I want to get any of these to where they are, I have to rotate them from one point to the other. So really from this point to that point, or these white ones from this point to that point. So really I can see the rotation symmetry is going to be 1, 2, 3 rotations. So that's my rotation on that. And if I'm going to rotate it, the question is, where would I reflect it? Well, it looks like if I'm going to reflect it, it's going to have to be where those points of rotation are. So to get those 3 yellow flowers back in the right place, or the 3 white flowers back in the right place, one of those lines of symmetry, there's one there, looks like there's one there, and there's one there. So it looks like I have just 3, 1, 2, 3 lines of symmetry. And since I had 360 degrees divided by 3, 120 degrees for each rotation. So each of those rotations is 120 degrees. So now let's look at the last of the kaleidoscope images, image F. And this one looks like it has lots of lines of symmetry. If I take my mirror, it looks like I can put it almost at any one of these lines, and I get the image back. I can go in the center between points and get it back. So it looks like there's lots of lines of symmetry. So all my lines of symmetry, so I have 1, 2, 3, 4, 5, 6 lines of symmetry. So now the question is, how much do I rotate to get from one point to the next? Well, if I take this purple edge here and I got to get it to that point there, and the same for the next. The next, it looks like I have 6 rotations. And each of those rotations, if I have 6 rotations, 360 degrees divided by those 6 rotations gives me 60 degrees for each of those rotations. So really I don't even need a protractor or a angle ruler at this point. If I understand all the way around is 360 degrees, and it takes 6 rotations, 6 moves to get it all the way back to its original point, then each of those rotations was 60 degrees, 360 divided by 6. And so now it's interesting if I just make a table of the results of these. If I take the images A, B, C, D, and E, and F, and I look at the lines of symmetry, I'm just going to call it lines of symmetry, LOS, and angles of rotation, so I'm going to abbreviate those. And you just take each one. Image A had 6 lines, and its angle is 60 degrees. So 6 lines, angle of rotation 60 degrees. And B had 3 lines and 120 degrees. So 3 lines and 120 degrees. And C, which was kind of an odd one with the words in it, had 0 lines and 120 degrees. D, 6 lines, 60 degrees. E had 3 lines, 120 degrees. And finally F had 6 lines, 60 degrees each. So 6 and 60 degrees each. Now, if you notice, the pattern, or look for a pattern, except for C, which is kind of an odd one, again, with the words in it. If you notice all of these, if I take the lines of symmetry times the angle of rotation, except of course for this one, for C, that they equal 360 degrees. Except for this one. And the question would be, why does this one break the rule? Because it looks like if you take the lines of symmetry times the angle of rotation on these circular images, these kaleidoscope images, you always get 360 degrees. So the part of the problem with the one with words is the design element in this one is not consistent. And so when you don't have a consistent design element, when you have really each of your parts are not the same, then it's going to be difficult to have any kind of reflection symmetry. And so in the case of C, because it doesn't have a consistent design element, we don't get this. But most of the time you can see that if you take the lines of symmetry times the angle of rotation, you're going to get 360 degrees. And in fact, in many cases, if you realize to find the angle of rotation, we took 360 divided by the number of lines of symmetry. 360 divided by the lines of symmetry gave us the angle of rotation. 360 divided by the lines of symmetry. And so we were actually using this to find those angles of rotation by taking 360 and dividing it by the lines of symmetry. So if we look at one more kaleidoscope, and this is in this problem 1.3, and we look at this last kaleidoscope, I'm zoom in a little bit more on it, see it a little bit better, and we're looking for, again, if this confirms the relationship, if we can find the angle of rotation, or if we can find the lines of symmetry. And the idea is that then we can take those lines of symmetry. This one is kind of a challenge, but if you look at, there's these little red spots in it. And the red spots, there's 3 of them. So if you think about that, it looks like our rotation, we're going to have a rotation, 1, 2, 3 rotations, or really, if you think about it, 3 lines of symmetry in this image. So if we have 3 lines of symmetry, and we think of this extra image now, 3 lines of symmetry times the angle of rotation is going to equal 360 degrees. So if this were true, then that would have to be 120 degrees for each of those angles of rotation. If we have 3 lines of symmetry, 120 degree angle of rotation will give us a total of 360 degrees. So we can kind of look at this and see, is that if I start here and I go from one point to another, and if I look at my protractor, it gives me 120 degrees. So my angle of rotation, 120 degrees, and then so I look at my rotation, 120 degrees, it could fold in half right there. You can see the 1/2 on the other. So there's 1, 2, and third, 3 lines of symmetry. So 3 lines of symmetry and 120 degree rotation. And we're going to stop there for lesson 1.3 and allow you to work on questions D and E on your own. And you can probably answer those questions pretty simply now based on the things that we've done so far in this lesson.